Welcome to solverfy.
Here we're going to look at an example of an energy level diagram with just 4 energy levels. Notice that they are all negative energies, which means that this is a bound system. So our electron is bound inside of the material. And the first question is, how much energy would it take to ionize this atom? We'll pretend it's an atom. And the idea is what you're doing is liberating the electron so it no longer has negative energy. So you're asking how much energy do you have to add to get the electron from minus 20 electron volts all the way up to 0 electron volts. And of course, the answer is add 20 electron volts. So that would be your ionization energy. The next thing to think about is suppose someone added 18 electron volts to the electron in the ground state. Okay, so clearly what will happen is the electron will get boosted up to the n equals 4 state. And the question is, what will that electron do? Well, it will fall back down to the ground state in many different ways, and we want to calculate all the energies that the electron could potentially emit. So that involves all pairs of energy levels starting with n equals 4. It can go to 3 or 2 or 1 initially. And we'll call those 1, 2, and 3. Well, if we don't have to number them, that could get confusing. And then it could wind up in the n equals 3 state, and then it will have 2 possible transitions. Or it could have fallen down to the n equals 2 state, and there's 1 possible transition. So let's just figure out all those possible energies. And there's also 2 electron volt emission if the atom was ionized, but here we're assuming it just got to n equals 4. So n equals 4 to 3 is a difference of 3 electron volts. 4 to 2 is 8 electron volts. And 4 to 1 directly is the full 18 volts of emissions. Then we've got n equals 3 going, whoops, wrong color. So we have 3 going to 2 is 5 electron volts. And 3 going to 1 is 15 electron volts. And only one more possibility. N equals 2 going to back to 1 is 10 electron volts. Okay, so the next question is, suppose that the particle, the electron, is in the ground state, and along comes an 8 electron volt photon. What will it do? So the electron is in n equals 1. And if we look at all the potential transitions, 1 to 2 takes 10 electron volts, and then there's some higher ones. What we see is there's not enough energy for that photon to do anything. And so the photon will go through the material. Photon does not interact and go on its merry way. Okay, and finally, let's see. The next thing is we are going to look at photons that come out of certain transitions in this material, and we will see what they do to another material. So this is kind of the photoelectric effect idea. So we're going to take the photons that come from this atom, and we can find their wavelengths, but we know that the 3-to-2 transition, which is a 5 electron volt, does create a photoelectric effect, and 3-2-1, which is the 15 electron volts, both of these cause photoelectric effect in some other material. We don't know what it is, but some other material. However, we find out that the 4-to-3 transition does not, and that's a 3 electron volt. No photoelectric effect. And of course, this gives us some information about the work function of the material. Recall that the work function is the minimum amount of energy or potential, depending on what units you want to use. Minimum amount of energy to liberate just barely liberate electrons from your material. And we see that whatever the work function is, let's call it W, it has to be greater than 3 electron volts, because 3 electron volts does not work. And it has to be less than or equal to 5 electron volts, because 5 electron volts is the first energy we see for which it works. And it may be a little bit less than that, so we'd have to have more data between 3 electron volts and 5 electron volts to identify that work function.